Okay, so the key thing, guys, to solving graphing problems correctly is first off to identify what kind of graph you're dealing with. Right? Because obviously solving for displacement on a position versus time graph is different than solving for it on a velocity versus time graph. Okay, so we're trying to find the total displacement of the object over the whole trip on this velocity versus time graph. So what we have to remember is on a velocity versus time graph, we have velocity and we have time. And if we want to find displacement, what do we have to do with those two things? We have to multiply them together, okay? Which is essentially like calculating the area under the line, okay, for something like this. All right, because on this one here, okay, in this section, okay, the first section here, the object is accelerating, so its average velocity is halfway between 0 and 60, which is half the height. So base times half the height is the area of the triangle. Okay, and then we'll have this rectangle here, base times height, okay, because its average velocity is 60, and that occurs for 5 seconds. And then we have the same thing over here, a triangle. Okay, so we've got that it goes from 60 to 0, so its average is 30, half the height, times the base, which was 15 seconds, right, and we'll have our totals. So your marks for that one will go as follows, okay? It's out of 4 marks, so I will give you a mark for each area calculation. Okay, so for the first one, 60 times 10 over 2 gives you the area here for the first one, which is 300. Okay, 60 times 5 for the little rectangle here, all right, is 300 as well, right? And 60 times 15 over 2, that should be 450. Yeah, I'm not sure why it's not on there, but say it's 450. And then when we add them all up, because they're all positive, we get positive 1,050 meters. All right? They do have to have the positive on there to get this right, because the graph clearly shows a negative portion, okay, being down here. So to get this last mark, they must have the positive and they must have the meters. And if they're missing either one, they don't get that mark. Questions on number 1? Question number 2 is a position versus time graph. So if I want to calculate average velocity, I need total displacement and total time. Agreed? Okay. So on a position versus time graph, to get total displacement, I take final position, which was negative 20, and I subtract the initial position, which was 0. So the total displacement is negative 20 meters. So you can give them a mark for knowing they had to use V equals d over t. Right, they can have 1 mark for that. Okay, they can have 1 mark for having negative 20 meters over 9 seconds. I don't really care if they had the units in that portion. Okay, as long as they have negative 20 over 9, they can have that mark. Okay, or maybe they showed the subtraction operation. I don't know. Okay, on there, and then their last mark is for negative 2.2 meters per second. They must have the negative and they must have the meters per second in order to get the full marks. Right? Because velocity is a vector quantity. Questions on that one? Okay, give them a mark out of 7. Let them see it. Put it in the box. Then take out your worksheet from yesterday. Okay, guys, I've had a few questions from people when they reach this graph right here. Okay, if I want to find instantaneous velocity from a position versus time graph, and my position versus time graph is a curve, the curve shape tells me the object's doing what? It's accelerating. It's changing its velocity. It's either accelerating positively or it's accelerating negatively. But in any case, its velocity is changing, and I can't calculate the slope of a curve. So we did something which was a little trick in order to find what the slope of that part of the curve was at that particular point. Anyone remember what we did? We made tangent lines, right? Okay, we draw a tangent line that touches the curve at the point they're asking. Okay, so if we're looking at, let's say, part A here, they want to find the instantaneous velocity at time 2 seconds, right? I need to draw a tangent line that touches the curve right there. All right, so that's what I'll do. I'll take, you know, like a ruler or something for you guys. Okay, for me, it's got to be the line tool. All right, and I'll draw a tangent line that touches the curve at that point, and I'll calculate the slope of that line. Now, is it possible that there's kind of a range of answers here? Yes. I mean, I have written there 3 meters per second, but there's a very good chance that the line I just drew is not going to be exactly 3. It'll probably be close, right? But it's probably not going to be exactly 3 because I'm not going to draw the same tangent line 2 times in a row. All right? So if yours is a little off of that, you're probably okay. If you got 9, it's probably pretty steep. Okay? If you got like 1, it's probably crossing the line somewhere. Okay? So just things like that. This should be around that number. Does everyone follow? Okay. Okay. So I've been looking over your graphing labs. I got a quick question for you because I saw this happen quite a few times. First off, in the analysis you were asked to calculate the velocity of the carts. And I told you you had to do that using what? The slope of the line. Okay? I had a number of people who just went total distance over total time. If you were just going to do it that way, why did you waste so much time drawing the graph? Okay? Like there was no purpose then in drawing the graph. The other thing I saw was a lot of people doing this. They picked one point on the line to do their rise over run, and it wasn't necessarily on the line, but it was like close. And then they said, my other point is 0. Does that line go through 0? So can you use 0 as the other point on your line to calculate slope? Nope, because that point's not on the line. Okay, you had one point on the line, but then you said, oh, well, I'll just use 0 for the other one. Guys, when Google Sheets spits out the equation and it goes y equals 0.33 x plus 0.035, it's telling you your line does not go through 0, 0. It goes through this spot when x is 0. Okay, you guys follow me there? That was the purpose of introducing you to y equals mx plus b, is so that you would understand what the parts of that equation are telling you. All right, so I had a number of people who just didn't do the analysis part of this lab correctly. Okay, even though in the podcast I did say specifically either use y2 minus y1 over x2 minus x1 or manipulate y equals mx plus b to solve for m. Okay, but a lot of people didn't do it that way. They just went v equals d over t, which you didn't need a graph for. Okay, and it did say specifically using your graph, not using your data table. Okay, does everyone follow me there? There's a bit of a difference. Okay,